Okay, so this is chapter 27, the triangles chapter of my book, Overcoming Digital SAT Math. So remember, if you have a copy of this, attempt it on your own and attempt corrections on your own first for the best results, and pay attention to the video description over time as I add things there that that you might find helpful. Okay, so one thing to remember with these is that the figures are not drawn to scale. So just because something looks like it might be equal in terms of like a side length or an angle, you can't just assume that. You have to only use the information you've been given. So be careful with that before, I just want to give that little preface, that warning. So for this one, it says, for the figure shown above, what is the value of x? All labeled angles are in degrees. So this is a 30, 60, 90 right triangle. Thank you guys for the likes. And so that means that if you're thinking about, we can use x for the same ratio thing, but you can use another letter if you're used to it, that the side across from the 30 is represented by x, the side across from the 60 is represented by x root 3, and the side, sorry, I'm trying to like make this not be blurry, and the hypotenuse side is going to be equal to 2x. So you'll see just from 14 equaling 2x, I can easily figure out what x is. X must equal 7. So I know x is equal to 7, which is what it's asking. So it's just going to be A. And I think 2 is over here. Yeah. So this is number 2. So we have this triangle shown above, and we want to know the measure of angle CAB in radians. So CAB right here. If you have trouble naming angles, by the way, a lot of students that I've worked with find it helpful to just look at like the middle letter and see it as that angle. So like they see this as angle A and it's the middle number, or middle letter, I mean. So that's something that can help you out. So we're trying to find the measure of that angle in radians. So let's see the triangle I have. So I know this is a right angle right over here because it's just going like straight up and straight to the side right there. So I have a 90-degree angle right here. And then this has the same x value as this, 4 and 4. So that means that the distance or the length of this side is just going to be whatever it is from -1 to 4. So to get from -1 to 4, I just have to go 5 up. So let's see if we could do something similar over here. Well, yes, we can. The y's are similar, or not even similar, they're equivalent. 4 and 4. So again, we can just say, okay, what's the distance from -1 to 4? Well, that's going to be 5. So that gives you this side length. So those are equal. So we have 2 equal side lengths for this triangle. So we have a right isosceles triangle. We know that in a right isosceles triangle, the 2 angles have to be equal that correspond to those matching sides. So this angle has to be 45 degrees. This angle has to be 45 degrees because 45, 45 plus 90 adds up to 180 degrees in a triangle. Now, if you've memorized your unit circle, you should know right away that 45 degrees in radians would be equal to pi over 4. But if you did not know that, you can always do that thing where like to convert between from degrees to radians, you just multiply by pi over 180 and simplify it. So you could do that as well if you don't have that memorized. So it would be C. Is this the actual SAT? No, this is my book that I've created based off of how the digital SAT exam is. Okay, so let's keep going to number 3. Does that math you are doing sometimes hard? That math is difficult to me when I am not familiar. Sometimes I make mistakes all the time on live, like I'll like misread an M as an N, like especially with variables that look the same like that. It's fine to like mess up every once in a while. It just takes like practice. And even if you have all the practice in the world, you're going to mess up a time or two. So sometimes it's hard in that sense. So let's go to number 3. Triangle PQR and STU are congruent right triangles where Q and T are right angles. So right away, I'm going to draw this situation. So I'm going to actually draw it up here. So I have PQR and Q is one of the right angles. So I'm going to say it's PQR like that. And then I'm going to do another right triangle where T is the right angle and it's called STU. And it said S corresponds to P, so that matches. Good. If S measures 14 degrees, so this is 14 degrees, and it corresponds to angle P, meaning this is also 14 degrees, then which of the following is the measure of angle R? So I want to know this guy right here. Well, you'll notice if these angles match, that means that these angles have to match as well. So R corresponds to U. I mean, you could figure out what U is and then just make it equal, or you could just say I have 180 degrees in my triangle over here and then solve for R. That's what I'm going to do. I mean, it's kind of the same thing, but I know that all three of these angles have to add up to 180 degrees. So I'm going to say angle R plus 14 degrees plus, that's a 90-degree angle, has to add up to 180 degrees inside of a triangle. So if angle R plus, and then this is going to be 104 degrees, is equal to 180 degrees. So then angle R has to equal 76 degrees. So the answer is C. Thank you guys for the likes. Please share and like this live so we can get it out to more people. It really helps out. And FYI, this is my book, and it's actually on sale for the next 2 days on TPT if you're interested in getting it. So let's go to number 4. For the figure above, what is the value of XY? Okay. I have a 45, 45, 90 triangle, meaning, in other words, I have a, what is it called? Isosceles right triangle. So this side has to equal this side because they're both across from equal angles. Like 45 matches up with this side, 45 matches up with that side. So the side lengths have to be equal. So I know that Y is equal to 6. So now I know what Y is. I have to figure out what X is to plug in for XY. This is a right triangle, so I could technically use Pythagorean theorem and do 6 squared plus 6 squared equals x squared, but that's going to take me a lot more time than just using what I know about special right triangles, which is that if I think about these sides as ratios, like I'm going to use a different letter besides x and y so that people don't get confused. I'm going to use z. If I think about the side lengths as the ratios of the side lengths, I could say that this is z, z, and that this is always represented by z root 2. So if I know z is 6, I could say this is 6 root 2 for x, for that side length. So now I can say, okay, x times y would be 6 root 2 times 6, which is just 36 root 2, b. Towards the end of the school year, can you do a history and algebra review? I struggle in those tests, and science. Like history, there's a lot going on there, so you're gonna have to be specific. But yeah, you can always, and also guys, if you have like specific questions that I don't answer, like I try to do what's most popular by doing math on the lives, because otherwise I get questions of people like, why aren't you doing math? But if you have specific questions, you can go to the Q&A feature on my profile or like tag me in videos and I can answer stuff for you if you want. But yeah, you could just like be more specific on there and then I can like do some videos or something on that. No problem, Haley. So let's go to number 5. So for number 5, it says triangle PQR and STU are similar triangles where PQR corresponds to STU respectively. So like P matches with S, Q matches with T, and R matches with U. So if the measure of angle U is 36 degrees and 1/3 PQ equals ST, then what is the measure of angle R in degrees? So I wrote this problem to be extra annoying. So R matches with U, right? And you're expecting like, hey, they gave me this equation. I'm going to have to use that at some point. But I just did that to be annoying. Since R corresponds to U, you know that they're equal in degrees. So since they told you what U is, you know what R is. So it's just 36 degrees. So let's go to number 6. Which of the following could be side lengths of a triangle? So this is, what's it called? The triangle inequality theorem. The rule that says if you add up any two side lengths of a triangle, that it has to be greater than like the other side length that you haven't added up. So for instance, with number 1, Roman numeral 1, if I add up 2 plus, why is it delayed? That's weird. 2 plus 6, I'm adding up two sides that has to be greater than the remaining side 8, which it's not. So that means that that's impossible. These are impossible side lengths for a triangle. So now I'm going to do something similar with Roman numeral 2. 9 plus 18 is definitely greater than 21, but I have to check the other sides. 18 plus 21 is definitely greater than 9, and 9 plus 21 is definitely greater than 18, so that checks out. Now, if you had just gotten this far on the test, just as a side note, you could cross out A and D, and if you have to guess, you have like a better chance now that you've eliminated half the choices, but we're gonna keep on going. So for number 3, or Roman numeral 3, I'm gonna now check, okay, 2 plus 10, that is supposed to be greater than 14, but it's not. So that can't work. And then, so it's only 2. And actually, what am I saying? I was reading this, I think, as like 2 and 3. So I was trying to check number 3. I could have just said it was B. I don't know what I was thinking. I didn't get the last question. Okay, so this last question, that it's basically doing that thing where it gives you extra information you don't need to try and trick you. So like the part I underlined, you don't even need. It's just extra information to throw you off. So when I say triangle PQR and STU are similar triangles, where P, Q, and R correspond to ST and U respectively, that means like P corresponds to S, Q corresponds to T, R corresponds to U. So if they're similar triangles and those are the corresponding angles, those corresponding angles must be equal. So it tells you what U is. U is 36. So then that means that R must also be 36. And for number 6, B is the answer, because if you add up all of the, like if you try adding up pairs of the side lengths, they're all going to be greater than the other side length. So like 9 plus 18 is 27. 27 is greater than the other side length, 21. You could do the same thing for the other ones. 9 plus 21 is going to be 30, and that is in fact greater than the remaining side length, side length 18. And then what's the one I didn't do? 18 plus 21 is going to be 39, and that is greater than the remaining side length 9. So that's the triangle inequality theorem that says you have to, if you add up the two sides of a triangle, it always has to be greater than the third side for those to be possible side lengths of a triangle. So that's why it's 2, or just B. Okay, so let's go to number 7 now. So in the figure above, AB is parallel to DE. What is the length of DC? So I'm going to label this as X for DC right there. So with these triangles, you have to remember that you can set up a proportion where 4 is to 6 as X is to 8. So 4 is to 6 as X is to 8. And then you're going to cross multiply to get 6x is equal to 32. And then you get x by itself by dividing by 6, so it's 32 over 6. If you divide by 2 on top and bottom, you're going to get 16 over 3, 16 thirds. So that would be what x is equal to. That's the answer. Okay, so let's go over here to number 8. A square cake is cut one time diagonally from one corner to another. If one side of the square cake measures 8 inches, then what is the length of the diagonal cut? And thank you guys for the likes. Please like and share this to get it out to as many people as possible. So we have a square cake. I know my square is awful, I'm sorry. So every side is going to be 8 inches of the square cake. And we want to find the length of this diagonal right here. So if it's a square, it has a right angle right there, right angle right there. So you see how both of these sides of this triangle are 8 and 8? That means I have an isosceles right triangle, also known as a 45, 45, 90 triangle. So I could just use the rules that I know about the ratios of the side lengths to say that this diagonal is equal to 8 root 2. So then it would be D. Now, if you don't remember that, or you're just bad with special right triangles, you could always just do Pythagorean theorem and say 8 squared plus 8 squared is equal to, we could call this x squared, and then you could solve and you would get the same thing. So either one works. So let's go to, wait, is it D? I have to leave, so can you tell me please? Yes, it is D. Sorry, I did not see that. So let's go to number 9. In the figure above, AC is equal to 14. So I'm going to start writing and drawing on this, that's 14. And then AB, this whole side length right here, is equal to 35. DE right here is 8. And we want to find out what is the length right here, BE. That's what the question's asking. So this big triangle is a right triangle, right? So I could find out what BC is by using Pythagorean theorem. And then once I find out what BC is, I could set up a ratio, because these are similar triangles. So I could set up a ratio or a directly proportional relationship that says something like 8 is to 14 as BE is to the whole side BC. Which it'll make more sense when I start going through it. I'm just giving you an overview. So let's start by finding out the side length BC. We're going to do that by doing 35 squared, that side length squared, plus 14 squared is equal to, and I'm going to say that this is just BC squared. So we're going to now solve for BC. Someone said, what grade is this? This is for the digital SAT math exam, which tests across concepts on various grade levels. So it's not specific to one. For a live format test review, you shouldn't assume people remember anything. Every problem, thorough explanation. I am giving a thorough explanation. I'm giving an overview first. So, we're going to find out what BC is using the Pythagorean theorem here. So 35 times 35, that's going to be 1,225, plus 14 times 14 is 196. So that's equal to BC squared. So then all I have to do is add this up and take the square root of that. So then that's going to be 1,421. The square root of that is equal to BC. And then I can just simplify this to find out what BC is. So let's see let me use my calculator because I don't feel like dividing by 29 right now. 1421. Whoops. 1421 divided by, does 29 go into that? Yeah. 29 times 49 gives you 1,421. This is a perfect square. So the square root of 49 would be 7. So I could say that this is equal to 7 root 29. This whole side length, BC, is equal to 7 root 29. Let me just erase this so I have room to write my next part that I'm going to do. So now I can set up a ratio with the side lengths. 8 is to 14 as, and then I could say, I'm going to call the question mark x, as x is to 7 root 29. And the reason I did that is because I know with similar triangles that the side lengths are directly proportional. So I can say that 8 is to 14 as x is to 7 root 29. You could also think small to big equals small to big, if that helps you, of the matching sides. So now I'm going to cross multiply and I'm going to get 14x is equal to 56 root 29. And then I'm going to solve for x by dividing each side by 14. So now I'm going to get that that's going to be 4 root 29. Let me just check that math. Yeah. I thought I did that wrong, but no, I got it. Okay, so then that's 4 root 29. That's all I'm solving for. So that's the answer, D. Okay, and then hold on. Sorry, there were comments and I wasn't paying attention. Hold on. Let me see if there was a question. I'm in 11th. This is easy. Okay. So it looks like we're going to go to the next one right here, number 10. Thank you guys for the likes. Let's see. If the lengths of two sides of a triangle are 5 and 11, then how many lengths are possible for the third side of the triangle, assuming that the third side is an integer? Okay. So how I typically teach this for the exam is I teach students that when they're asking about like the possible third side of a triangle, you basically want to say that that possible third side, which we'll call x, is going to be between the difference and the sum of the other two sides. It's just like a quick kind of like formula way to see the, because this is based off of the triangle inequality theorem, the one that we did a couple problems back, that says that if you add up two side lengths of a triangle, that it should always be greater than the third side that you obviously haven't added up yet. But this is kind of just another way of kind of viewing that helps us with this problem. So if two of the side lengths are 5 and 11, the difference between that would be 11 minus 5, and the sum would be 11 plus 5. So that third side length has to be between 6 and 16. And it's asking how many side lengths are possible for the third side length. So you could have x equaling 7. I'm not going to write it all out, but it could equal 7, 8, 9, 10, 11, 12, 13, 14, 15. All of those are integers between 6 and 16. So that would be, that's 9 possible ones. Yeah, 9. So there's 9 possible options for that third side length. So let's go to this one right here. Oh yeah, and I put like this little disclaimer because I wrote this just for people that are questioning that when they see it later on YouTube. I'm just saying that you would see like one of these problems in isolation. The only reason I combined them was because it was more efficient for you reviewing this way, and also it saved paper if you wanted to print it. So what is the perimeter of the triangle for this situation? So a kindergartner is drawing a picture of a house. The kindergartner decides to draw a square for the main part of the house. So I'm going to do a square. And an equilateral triangle for the roof of the house. Assume that the roof is drawn directly on top of the square. Okay, I already did that. With no space in between the square and the triangle. The square has an area of 36. So the square has an area of 36. So area of a square is equal to the side length of that square squared. So that means that some number for the side length squared equals 36, meaning the side length must be 6 on every side for this square. And we know that the triangle up here is equilateral, meaning all the side lengths are equal. So the side length should be also 6 for that triangle up top. So if we want to know the perimeter of the triangle, it would be 6 plus 6 plus 6, which is going to be 18. So now, oh, and I wrote a note for when I do this. What is the area of the triangle? 2 ways. Oh, I wanted to point out that there's 2 different ways that you could do this. So there's the most efficient way, which would be the second formula here, which this is not the area for any triangle. This is the formula for the area of an equilateral triangle. So since we know this is an equilateral triangle, if we want to find the area, we have 2 formulas we could use. Area of an equilateral triangle is equal to root 3 over 4 times the side length squared. So if I'm going to use that, which I'm going to do first because that's the most efficient method, it's going to say that the area of this triangle is that times, and then the side length is 6, so times 6 squared, which is 36. Then I could cross cancel, say 4 goes into 4 1 time, 4 goes into 36 9 times, so then it's just area is equal to 9 root 3. So I would know A is my answer. That's the fastest way. Now, a lot of people don't have that formula memorized, so if you don't have that formula memorized, then you can, I'm glad that you got a 1530. I'm very happy that you got that. Congratulations. Awesome job. And thank you for the praise. So the area of any triangle can be represented by 1/2 times the base times the height. So we're going to, so what you could do instead, if you didn't know that formula, is you could say, oh, I'm going to try to figure out what the height is, because I could turn this into like two different right triangles instead, like two 30, 60, 90 right triangles. And then I could solve for what the height is, this dotted line, because it splits this into 3 and 3. So then I have that side length 3, that side length 6, and I'm finding this missing side length for the height. And then you could do half of that times 6 for the base right over here, and that would give you the area of the triangle. So there's two ways to go about it. I got a 730. Congratulations, Sam, on your 730. And let's keep going to, let me get water really quick. Okay. And let's go to number 13. Oh, wait, actually, I'm supposed to be making sure that there's no mistakes on the answer key while I do this. I get caught up in stuff and I don't do that. Hold on. Whoopsies. So, number 11 is 18. Number 12, yes, good. Okay. So, let's go to number 13 now. What is the sum of one angle in the square and one angle in the triangle? Well, the square is easy because it's all right angles, so 90 degrees for the square. And then for the equilateral triangle, since it's equilateral, we know every one of the angles is equal. So every angle has to be 60 because 60 plus 60 plus 60 is 180. So 60 plus 90 would be 150. So that's the answer there, 150 degrees. Okay, and that was number 13. And then this is the trapezoid that we're using for the next two problems. Oh, I just saw a typo. That should say 14 and 15. Or 14 or 15. Let me just highlight that so I remember to fix that. Okay. So, what is the perimeter of the trapezoid? Now, the reason that this is in the triangles chapter is because you don't need to memorize like the formula for stuff like area of a trapezoid or anything like that in order to solve this problem. And a lot of students get stuck because they're like, I don't remember whatever the formula is that I have to use for the trapezoid. Remember, a trapezoid is just a rectangle and a triangle. So you can think about each of the parts individually and then use that information to help you figure out whatever it's asking about the whole entire trapezoid. And this is also an example of why it's important to not base like what it looks like as the scale, like it's not drawn to scale, because look, this whole side length is 21 because it needs to match that upper side length on top. And that means that this side length has to be 20. Like that's obviously like drawn disproportionately. Like we wouldn't typically draw that if we were drawing it to scale in this way. So it's kind of like an extra trick thrown at you, kind of. So just be careful about that. So I'm going to draw a height down here so that this is a right angle, so that I have a rectangle and a right triangle right there. I want to find the perimeter. So I know this whole thing is 41. And then basically to find the perimeter, I just need to know what this missing side length is right here, the hypotenuse of that triangle. Well, I know that this height is 18. So to find that missing length, I could just use Pythagorean theorem. So that's what I'm going to do. So I'm going to say 18 squared plus 20 squared gives me x squared. So I forget what 18, I know that's 400. I forget what 18 squared is all the time. It's so bad. I've done it so many times and I can't memorize it. 324 plus 400 is equal to x squared. So then that's going to be 724 is equal to x squared. So then I have to square root each side to get x by itself. So then that's going to be the square root of 724 is equal to x. And let's see, that's probably going to have like a root 181 based off the answer choices, possibly. Let's see, 181 times 4. Yeah, 181 times 4 gives you that. So then I could take out the perfect square, because square root of 4 is just 2. So I could say that x is equal to 2 root. Okay, so x is equal to 2 root 181. Sorry about that. So x is equal to 2 root 181. So now to find the perimeter, I just need to add up every single side length. So that's what I'm going to do. I'm going to say that the perimeter is equal to 41 plus 21 plus 18 plus 2 root 181. So obviously I can just easily add up like the regular numbers. So that's going to be 62 plus 18 is 80 plus 2 root 181. So that would be B. There. And let's go to number 15. So what is the area of the trapezoid? So the area is going to be the area of the rectangle plus the area of the right triangle right over there. So the area of this rectangle is just going to be length times width. So it's going to be 21 times 18. So 21 times 18, because I'm lazy, I'm using a calculator, 378. So this area, just the rectangle, is 378. Now I have to find out the area of this right triangle right over here, which is just going to be half of base times height. So it's going to be equal to half of base and height are the side lengths that make a right angle with each other. So half of 18 times 20. So then that's just going to be 9 times 20, which is 180. So I have 180 right there. So now I just need to add 180 plus 378, which I'm not even going to try and chance that by doing that in my head. 558. So that would be the area of the trapezoid. Thank you guys for the likes. And where's 16? Oh, there it is. So number 16 says, if the side lengths of two sides of a triangle are 4 and 7, then what is one possible length of the third side of the triangle? So that's that formula that I was talking about before. Again, where it's going to be that the possible side length or side lengths are going to be between the difference of those two sides you're given and the sum. So we have to do 7 minus 4, and then we have to do 4 plus 7. So it's going to be between 3 and 11. So any number between 3 and 11 works. So I could just pick like 4, for instance, and that would be fine. So let's go to number 17. A triangle has two side lengths that measure 12 and 17 respectively. If two angles of the triangle are congruent, then what is the greatest possible value of the perimeter of the triangle? So we have that two of the angles are congruent. So you have to remember that like angles in a way match up with the side lengths that they're across from. So if two of the angles are congruent, that means that the two side lengths that are across from them have to be congruent as well. So if we want to have the greatest possible value for the perimeter, we want to have the greatest possible number that missing side length can be. Well, that missing side length has to either be a 12 or a 17 because it has to be congruent with one of the other sides, and it would give us a greater perimeter to say that missing side length is 17. Because when we do 17 plus 12 plus 17, we're going to get a greater perimeter than if we just did 17 plus 12 plus 12. So this would give us the greatest possible perimeter. So when we add that up, that's going to be 46. Okay, so let's go to... Sorry, let me get water really quick. Okay, so let's go to number 18 now. ABC is similar to triangle DEF. Okay, and we want to know the perimeter of triangle DEF. Okay, I'm just going to draw two random triangles. So A, B, C. AB is 8, AC is 6, and BC is 11. And then we're going to do D matches up with A, E matches up with B, and F matches up with C. It's not pointy, but whatever. And then we're going to say that DE is 12. And we want to know the perimeter of this whole thing. So remember, similar triangles have proportional side lengths. So that means like the matching sides, you can set up a proportion with them. So like 8 is to 12 because those are the matching sides. 8 is to 12 as, and then you could say like 11 is to EF, for instance. And then you could cross multiply and solve for EF. So let's do that. 8 times EF equals 11 times 12, which is going to be 132. So then I'm going to divide by 8 on each side. It's going to cancel out there, and then I'm going to have that's going to be 1 and... Wait, hold on. I'm blanking out. Hold on, it goes in one time, so then that's going to be 5, 52. Okay. I don't think that goes in evenly, does it? 52 and 8? No. So, hold on. I can't do stuff in my head when it gets later. It just does not work out. So, that's going to be 5, yeah, 52. So, 8 goes into 52. That's going to be 6 times. 6 times 8 is 48. So, then we're going to get 4. So, it's going to be that and 4 eighths. So, 16 and 4 eighths, which is 16 and a half. So, 16.5 right over here. And then we could do the same thing, but with the side length DF. You could say 8 is to 12 because they match, as 6 is to DF because they match. And then cross multiply. So 8 times DF is equal to 6 times 12, which is 72. And then we divide by 8 on each side to get DF by itself, and that's going to give us 9 for DF. So then to find the perimeter, I just have to add all these up. So that's going to be 28.5 plus 9, 37.5 is our perimeter. Ooh, that looks bad. That's supposed to be a 37.5. Just trust. Okay. So let's go to number 19. For the figure above, what is the value of x? So it's a right triangle. So I know right away I can use Pythagorean theorem. So Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are these, your legs, the ones that touch the right angle, and c is your hypotenuse right over here, x plus 3. So I'm going to have x squared plus 6 squared is equal to x plus 3 squared. Now x plus 3 squared is the same thing as saying x plus 3 times x plus 3. And I have to FOIL that out because whenever I have two terms plus or minus in parentheses times 2 terms plus or minus in parentheses, I have to FOIL, which is an acronym that stands for what I'm multiplying. So F stands for, I'm going to multiply the first things together, x times x, that's x squared. O stands for outer things I'm multiplying, so 3 times x is 3x. I stands for multiply the inner, so 3 times x is 3x. And then L stands for multiply the last, so 3 times 3. And then that's all going to be equal to, I haven't done anything with this yet, so I'm just going to copy that over. Now I'm going to combine these like terms to get 6x. So, and also while I'm at it, I can just cancel out an x squared on each side because I can subtract x squared, it cancels out. So 6 squared is 36, and that's equal to 6x plus 9. I subtract 9 on each side because I'm trying to get x by itself. So when I do that, I'm going to get, 27 is equal to 6x. And then I'm going to divide by 6 on each side. And that's going to give me 27 over 6 is equal to x. Hold on. I feel like that is wrong. Wait. Did I do? Wait. So then that goes in 4, and 3, 6. So that's 4.5 is what x is. Let me just double check that. That's 19. Yeah, it's 4.5. Okay. For some reason, I thought I remembered that this wasn't a decimal when I did it, but I guess it is. So that's the answer for what x is. Okay. So let's go to number 20. If an isosceles right triangle has a hypotenuse that measures 6 inches in length, then what is the perimeter of the triangle? So let's draw that. So an isosceles right triangle is just another way to say a 45, 45, 90 triangle. So 45, 45, 90. And the hypotenuse measures 6 inches. And then remember, if it's an isosceles right triangle, that means that the legs, these side legs that touch the right angle, have to be equal to each other. So, and also you could say that the 6 is equal to x root 2. You could use Pythagorean theorem also, I guess, if you wanted to do that, but I feel like this would be faster. I mean, it depends on you. So I'm going to solve for x this way, and then I'm going to, once I have x, just add up all the sides to get the perimeter. So I'm going to divide by root 2 on each side, so then I'm going to have 6 over root 2 is equal to x. Now remember, we don't like having radicals on the bottom in math, so to get rid of it, we have to do root 2 over root 2, multiply by that. And then that's going to give me 6 root 2. Oh, let me write that better. That's terrible. That's going to be 6 root 2 over 2 is equal to x. So then if I do greatest common factor, which is 2 dividing by 2 on top and bottom, I'm going to get that this cancels out to 1, and this is 3 root 2. So x is 3 root 2. So I have x equaling 3 root 2, and it's the same there. So it's going to be 3 root 2 plus 3 root 2 plus 6. So 3 root 2 plus 3 root 2 plus 6 gives me the perimeter. Ooh, that looks bad. Okay, and then that's going to be, I combine like terms here to get 6 root 2 plus 6. So that's going to be C right there. Thank you guys for liking the live. Give me 1 second to do something really quick. Okay. And let's go to number 21. Okay, okay, so it's the same situation, but now finding the area. So we're going to do area is equal to half of base times height. Now, remember, base and height are the ones that make the right angle with each other. So that means my base is 3 root 2, and my height is also 3 root 2. So it's just 3 root 2 times 3 root 2 times 1/2. Or like the other way around, doesn't matter. So that's going to be 1/2 times 3 is going to be 9, and then the root 2 times root 2 is just 2, so it's technically like 9 times 2. So then that gives you 18. And then now 1/2 of 18, that's just going to be 9. So the correct answer would be B. Whoopsies. Let me just erase all of this. Doesn't get all messy. Okay, and then number 22 says triangle ABC and DEF are similar triangles where D corresponds to A. Given that, so D corresponds to A, yeah, that matches. Okay, given that 22 degrees is the measure of angle A, so I'm going to write in 22 degrees right there. What is the measure of angle E in degrees? So this is the question being asked right here, the measure of that angle. Now, if D corresponds to A, that means that they're equal to each other. So this is also 22 degrees. Now, this is one of the ways that they're asking questions now on the digital SAT. Like, they might have asked you something similar before, but, like, this is the specific, like, this is more specifically, like, one of the things that's changing about the exam. So I would pay extra attention to, like, this problem. So I know that that mystery angle plus 90 degrees, because a right angle is 90 degrees, plus 22 degrees has to add up to 180 degrees. So I'm going to write that as an equation, and then I'm going to solve for x. I'm going to call this angle x. So x plus 90 plus 22, which is just going to be 112 degrees, is equal to 180 degrees. So then I just have to subtract 112 degrees from each side, and that's going to give me 68 degrees is my answer. So that's what you get for 22. Thank you guys for liking and sharing the live. So that is it for the triangles portion, or triangles chapter. Does anybody have any questions about digital SAT stuff? Or ACT prep stuff, college consulting stuff? I can answer any of those in the comments now. Yes. Someone said they have one, so just put it in the comments and I'll answer it. Is this geometry? So like, this is for the digital SAT exam, but some of these concepts do fall under geometry. Some of it also you get taught in like pre-algebra and stuff. So it's like, it spans, it's not just like one specific class, if that makes sense. And like sometimes like triangle stuff will be like trig stuff. Like it's not all just in one. I passed my exam. Awesome. Good job, Destiny. One of my teachers taught this stuff. Maybe. Because you have to do, like, you have to think about it, like, it's a lot of, like, not just, like, one concept. Like, you have to have algebra involved, like, if you're solving for X and, like, stuff like that. So it's not, like, just geometry. Taught, yeah. I figured that's what you meant. Anybody else have any other questions? And remember, if you're interested in getting this, it's on sale today and tomorrow on Teachers Pay Teachers, which is linked in my website in my profile. Okay, I don't think we're getting any other questions, so I'm going to head on out. And I will definitely be doing a live next week on Monday at 6 p.m. Eastern time, and I'll let you guys know via like my stories on TikTok if I decide to do like an extra live before then. Bye guys.